Hi, I'm Alex Kinn. I'm in the ecology for environmental science major at UNT, and I am looking at nesting productivity in a species of hawk called Harris's hawks in South Texas.
Why is the research you're doing important?
So the research that I'm doing is really important because I'm basically assessing how drought and changing climate variability and stuff is going to influence top predators in our ecosystems. And so Harris's hawks in the Rio Grande Valley, which is my study area down by the border, kind of near Guadalupe Island and stuff. They're very important in their ecosystem because they are a top predator, and so they're very important for like prey abundance. So by keeping like rodent populations in check and stuff, then that's going to help like vegetation. It's going to overall maintain the ecosystem. So by looking at how drought and the changing climate in South Texas is impacting these predators, we can get a better sense of what's going to happen to the landscape overall in the years to come if climate change continues the way that it's going.
So what sparked you into choosing the research you're doing? Why birds? Why the hawk?
Well, first and foremost, UNT is a big bird school.
That
If
is
you're an ecology major, we've got the blue jay boxes around campus. We run an American kestrel project. We have a painted budding project down that runs in Leela. So we're a big bird school in general. So it was relatively easy-ish to get into. There's a professor here who takes undergraduates for bird banding every semester, which is basically where we ran a banding station, which is where you put like those little metal rings that they put on like bird legs and stuff to keep track of them.
Yeah.
Yeah, so we run a banding station down in Louisville. And so I got invited to participate on that during my freshman year, which is where I met Brooke Poplin, who's the grad student that I worked with. And she basically said to me, I'm going to go to South Texas for 2 months to study hawks. Do you want to come with me and stuff? And I didn't have much else going on. And so I was like, yes, sure, we'll go to South Texas for 2 months and everything. And I really did love it. There was definitely a lot going on. I'm very glad that the two of us got on because it was just the two of us for those months in that little house. We watched a lot of RuPaul's Drag Race.
Yeah.
And so after that and everything, I ended up deciding that I wanted to do a thesis through the honors college because they were basically saying, oh, you have all these credits and everything. If you wanted to complete a thesis and get in, I think it's like some sort of honorary medal thing. They basically told me that they were going to give me a medal if I did a thesis. And I was like, yes. I do like medals.
Yeah.
I'm a big fan of medals. So I decided to do that and stuff. And so I reached out to Brooke and said, hey, I was wondering if we could come up with a project for me to do essentially. And she had been thinking of doing this project as part of her master's degree, but didn't really have time for it. And so she helped guide me and kind of helped me come up with the basics of the project, gather the data, and kind of walked me through what to do. And then after that, it was mostly me Googling how to use ArcGIS in RStudio.
Yeah. So what does a typical day for you look like, especially when you're doing your research?
So when I was out in the field a couple of years ago with a graduate student named Brooke Poplin. We lived down in South Texas on a nature preserve, just the two of us, for 2 months together. And we did mostly field observation studies and nest searches. And so we would essentially get up every morning at maybe 6 or 7 in the morning and go out and find the birds that we already knew where they were. Since the UNT, like kind of our ornithology program and stuff, they've been running this study on Harris's hawks for quite a while now. They've had 2 different student researchers run the project before me. And so they've had multiple people who've already kind of gone down there, looked, and they kind of know where the birds are and know where the birds' territories are. Oh. And so we would go out and basically check them every day on a kind of a schedule and stuff. So one day we would go to a certain area of our study area, check on the birds, note who we saw, where we saw them, what they were doing. We sometimes did behavioral observations where we would watch them for a few hours or so. And we were basically just looking to see kind of what they were up to throughout the day and stuff, and how their group composition and everything worked as like group hunters. And so where my research came in is I basically started looking at our nesting productivity. So while we were down there and observing the birds, we were also taking note of where they were nesting if they had nested or if they had decided to forego nesting. And so for the research that I'm currently doing, I've basically taken all of that nesting data that we found, and most of it was through foot surveys. So essentially, she tricked me into going down there and walking around with her for like hours and hours at a time.
Looking for
just
the nest? Or?
Looking
Wow,
for the nest. Yes, like crawling around through the bush and everything. And so when we found it, it was a big thing of, oh my gosh, yay, we found it and everything. And so basically, I'm just taking the data of, did we find a nest in these territories in these certain years, and comparing that with the drought conditions in the years at those times.
So currently, how do you feel about the accomplishments you've like earned from doing your research, like the new findings you've had?
I feel very accomplished about it, actually. We ended up finding some really interesting stuff. So basically, the results of my project, essentially what I did was I took this measure, this vegetation metric called NDVI. NDVI is the Normalized Difference Vegetation Index. What it essentially is it's a measure of how green plants are. And so theoretically speaking, the more green plants are, probably the more productive they're being, right? That really demonstrates to us that they're having a lot of photosynthetic activity and stuff, that they're probably producing a lot of energy and everything. And so what I essentially did was I took satellite images from NASA, like NASA's satellite images, because they take images almost every day of what the Earth looks like and everything. So I took those images from the certain time period. I did them all from the month of June, from all those years I mentioned before, those last 5 years and stuff. So for all 5 of those years, I found an image from one day in June that had like the least amount of clouds in it, that kind of looked the best, that was easiest to work with.
Yeah.
And I assessed in that image using a program called ArcGIS, which is a map making software. And I extracted like the values from, it's kind of complicated to explain. I quite literally extracted how green the greenery was from like the red and green like spectral bands in the image. It sounds really complicated. It's not. I basically just took like every red and green layer out of the image and made that into a value that we could quantify, right?
Yeah.
This area on a scale of 0 to 1 being it's very green and very dense, 0 being it's very sparse and not green at all. Then we can kind of look and say, okay, in 2018, it was more green, which probably leads us to believe that there was probably more water available and more productivity happening.
Oh, okay.
And so that's essentially what I did. And then I compared that with our nesting data. So for all those years, what territories did we find a nest in? What territories did we not find a nest in? And then through a bunch of complicated computer modeling and stuff that we don't need to get into, we were basically able to determine that overall, first of all, the NDVI range, so not necessarily the maximum, which would be it's very wet, or the minimum, meaning it's very dry. Those didn't end up really mattering. But the range itself was what mattered. So what we ended up determining was that NDVI range, and then we also looked at different land cover types. So we looked at wetland, shrubland, and cropland. Yeah. Basically, that way I wasn't looking at like urban areas, where urban areas like UNT, our NDVI is probably relatively high because we have like irrigation and we have people who are watering the plants and stuff. Yeah. But we wanted to avoid using any of the buildings or anything because that's going to obviously cloud up, because it's going to say that the buildings aren't green. So it's going to lower the NDVI. So I just looked at those specific land cover types. And what we ended up seeing was that the maximum and minimums of those values did matter. So what that kind of leads us to believe is that the overall range of NDVI is what matters. So it's not that it's really, really good for the vegetation to be super duper green and dense. And it's not really, really bad for it to be super sparse and dense. But when it's very variable, that's when hawks don't want to nest. Oh, so if it's too green, then we can kind of assume, okay, there's probably so much vegetation that they can't catch prey, right? There's got to be some drawback, because if I'm hunting mice and we've had so much rain that there is just leaves everywhere, I'm going to have a really hard time finding mice. Yeah. Versus if there's no water available, then I might have a hard time having enough nutrients to even begin nesting. So what we ended up determining was basically that what matters in the end is the NDVI varying a lot during the year. And so when variability is low and NDVI is kind of more average, more moderate, not too green, not too sparse or anything, that's where we're going to have the most nesting productivity. And so that's kind of really interesting idea, is because initially we were pretty much set on, okay, if there's a higher NDVI, there's more water, that means that nesting productivity is going to be higher. But finding instead that it was the variability that mattered points us a lot to like what we're going to see with issues with climate change in the future, because with climate change the ecosystem is changing so much and the climate's going to change so much, and so it will be less about is this region experiencing more drought versus is this region just going to experience a lot of change and stuff.
Yeah. So what do you hope to learn or find out at the end of the research?
So what we really would hope to do is, so my research is kind of coming to an end now. I'm graduating at the end of this fall and everything. I'm kind of wrapping my project up. I'm presenting it at a couple conferences and stuff. I'm taking it to the Raptor Research Conference here in a couple weeks in October in Costa Rica, which will be cool.
Oh, that's awesome.
Yeah, I'll be giving a talk over and everything. So as this project kind of wraps up, I would say what we kind of hope for in the future is probably more studies looking at how predators are going to respond to vegetation metrics like NDVI, because all NDVI really means is that NDVI means kind of what's going on with the vegetation in terms of drought and drought conditions, right? So it's less about, hey, the vegetation's really green, so the birds are nesting better, blah, 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 blah. It's more about, well, let's look at how the climate's changing overall and how yearly NDVI can kind of tell us about what's happening to the climate and what's happening with drought in South Texas. And so hopefully in the future, we can use studies like this to look at other kinds of predators. So not just hawks, but maybe how are coyotes doing, right? Or how are, you could even look at alligators down in South Texas, right? Ocelots are a big thing down in South Texas that they're trying to conserve and everything. And so different predators like that might respond in different ways to the variability in vegetation. And so hopefully by starting to predict and say, okay, if we need these predators to maintain some sort of ecosystem balance, how can we best help these predators in a changing ecosystem so that we're still able to maintain balance with the years to come and everything.
So last question I'm gonna ask you. What do you do for like fun or to like entertain yourself, especially when you're not working on your research?
I walk my dog a lot. Seems like I'm always walking my dog. We go hiking a lot. We love to camp too. I know you said you were interested in camping, awesome, but we love to camp and go hiking. I love to go to like Colorado and Idaho especially too, are some of my favorite places. So we hike and camp, and I like to read and go out with my friends because I'm a very typical 21-year-old.
Yeah, that is awesome.
You know, go to Fry Street and everything.
Yeah.
Terrible place to be,
yeah. But yeah, no, I think that's gonna conclude our interview for today. Thank you for teaching us a little more of what you do on a day-to-day basis, and especially more about your research.
Thanks for having me.
Of course.